Hi, boys and girls. We are on Chapter 6, Lesson 3, and it is called Simplest Form. All right? Of course, we're on fractions, and when a fraction is in simplest form, you are writing what that fraction is in the lowest possible numbers, the smallest possible numbers. Okay? We are looking at number 5 first. So number 5 is 100 over 100. So 100 over 100, if you were going to draw that, which we're going to not draw 100 pieces, but go back to your days where you use base 10 blocks, which you still use them now. Remember the big base 10 block, right? Okay. How many pieces were in that base 10 block, the flat? There were 100 pieces in it. Okay? So now let's think about what a fraction means. The top number is how many pieces we're talking about, or how many pieces sometimes are shaded, or maybe we're talking about the not shaded pieces, but that's what we're talking about, 100 pieces. The bottom number is how many pieces make a whole, either a whole set or a whole thing. Okay? So if you have 100 of the pieces that make this flat, what do you have? You have the whole thing, right? Okay? So if you have 100 out of 100, you have one whole thing. If you have a pizza cut into 100 pieces, and you have all 100 pieces, you have one whole pizza. Okay? And we can think about it. I know you guys have learned to divide and divide. So let's divide by 100, top and bottom. 100 divided by 100 is 1. 100 divided by 100 is 1, right? So 1 over 1 equals 1 also. Okay? Anytime you have the same number as the numerator and the denominator, you have one whole thing. Now let's go to number 6, 2 sixths. All right? So if you have 2 out of 6 equal parts, yeah, that's what I could do. Boop, 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 boop. Okay? 6 equal parts. So you have 2 of them. 1, 2. Okay? We are going to simplify that. We are going to write that in the lowest terms we can think of, the lowest numbers we can think of. So, look, I can put 2 of the pieces together there, 2 of them together there, and 2 of them together there. So I can put the 2 pieces into 1 and call this area, instead of 2 sixths, 1 out of 3 pieces. So what did I do here? I'm going to divide the 2 pieces by 2, divide the 6 by 2. Because if we divide the number of pieces we have to divide how many pieces makes the whole thing. 2 divided by 2 is 1. 6 divided by 2 is 3. 1/3 is 2 sixths in simplest form. And it's right there. Okay, there's the model. All right. Now, what you are looking for is a factor that both the numerator and the denominator have in common. Numerator, denominator. All right, now in this problem, it's probably screaming out at you, right? If you have to list the factors of 2, it's just 1 and 2. Those are the only ways you can make 2. If you list the factors of 8, there's 1 times 8 and 2 times 4. Okay? So the only factor that they have in common is 2. So we are going to divide both the numerator by 2 and the denominator by 2. This is one of the reasons that we had that long lesson on finding common factors and what a factor is and all that good stuff. 2 divided by 2 is 1. 8 divided by 2 is 4. 2/8 in simplest form is 1/4. Now, if you get stuck on these divisions, even basic fact ones like that, because lots of kids do, okay? If you see 8 divided by 2 and you're like, I hate division, boo. Remember, you can go right to left and think, what times 2 is 8? Okay? Because they're opposite operations. They're inverse operations. So really, what times 2 is 8? 4 times 2 is 8. Same with up here. What times 2 is 2? 1 times 2 is 2. All right, let's keep going. All right, guys, now we're looking at 14, 15, and 16. And in these, we have to decide whether the fractions are equivalent or not equivalent. Equal or not equal, really. Okay, so we're looking at number 14, 11/12 compared to 9/10. Okay, so when I look at those, I know 11 is a prime number. That's going to be hard to divide, right? You can only divide it by 1 and 11. So what I'm going to do is use the things that I know about fractions, because you know a lot about fractions too. And when we think about 11/12, okay, oh, that wasn't very good at the end. 11/12, we know that we have everything except for that one part. And when we have 9/10, let's take a look at that. Okay, we have everything. We have everything except for that one piece, right? These fractions are both one piece away from being the whole thing. If I had 12/12 of that candy bar, I'd have the whole thing. That's one piece away from 11/12. If I had 9/10 of this candy bar, I would have almost the whole thing, because 10/10 would have been the whole thing. So I'm really close to having the whole thing in both of these. I'm one piece away. So we have to think about the size of that piece that's not there. If I'm sharing with 12 people, my pieces are not going to be as big as if I'm only sharing with 10 people. These pieces are smaller than these pieces, okay? So when I look at what I have in 11/12, I have a lot, except for that little small piece. In 9/10, I have a lot there too, but I don't have as much as 11/12 because that piece is bigger. I only cut 10 equal parts instead of 12 equal parts. So since these two are one away from being a whole thing, and I know that one piece is not the same size, this is a not equivalent situation. Okay? That's a great strategy for comparing fractions, guys. If you think if they are one piece away from being the whole thing, you can just think about the size of that missing piece. All right, let's look at number 15. 2/5 compared to 8/20. Oh-dee-doo-dee-doo. Let's see. Oh, you know what? What was this lesson about today? It was about simplest form, wasn't it? So when I look at 5 and 20, I'm pretty sure I can get 8/20 to a fraction with my friend 5 in the denominator. Because if I have 5 in the denominator, and 5's up in this denominator, I can just look at the numerator and say, are you the same or are you not the same? And compare them that way. So let's see. 8 and 20. What factor do they have in common? Well, I know you guys, some of you guys do little T-charts for factors. 1 times 8, 2 times 4, and then the factors of 20. 1 times 20, right? 2 times 10, 4 times 5. So they have the factor 2 and 4 in common. So let's use 4. We're going to divide by 4, divide by 4. Yeah, 20 divided by 4 equals 5, right guys? This is going to work out perfectly. 8 divided by 4 is 2. So 8/20ths in simplest form is 2/5. Now look at that comparison. 2/5 equals 2/5, or 2/5 equals 8/20ths, or is equivalent to 2. I keep forgetting to say that. All right, guys, let's look at number 16. Oh, I love number 16. 4/8 compared to 1/2. Are they equivalent or not equivalent? What is something really special about 4/8? Right? What's 4 plus 4? What's 4 times 2? 8. 4 is half of 8. Right, guys? So if we had a little candy bar, okay, 1, 2, 3, 4, 5, 6, 7, 8. If I had 4 out of 8 of those pieces, would I have the exact same amount as half? Absolutely. Equivalent. Those are equivalent fractions. And we also could have done 4/8 in simplest form. Gosh, I keep picking bad colors. 4/8 in simplest form. Okay? They have a common factor of 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 4/8 is equivalent to 1/2. Lots of awesome strategies, and all 3 of them are amazing. Well, this one we drew a model, and then we did the division for simplest form. Division for simplest form, and we drew a model here, but remember we looked at these were both 1 away from the whole. All right, let's keep going. So here we are problem solving at the bottom of the page. Okay, let's read it together. At Memorial Hospital, 9 of the 12 babies born on Tuesday were boys. In simplest form, what fraction of the babies born on Tuesday were boys? Well, let's see what they said here again. At Memorial Hospital, 9 of the 12 babies were boys. So they want to know in simplest form what fraction of the babies were boys. Okay. The number of babies that we're talking about, 9 boys out of the whole set. The set is 12 babies. All right, so let's do simplest form here. We have to find a factor that they have in common, because we need to divide both 9 and 12 by the same number, because we want to write something equivalent to 9/12, but in the smallest possible numbers. All right, let's think about 9, 12. I'll do these little T-charts again. I know a lot of you guys use those. 1 times 9 is 9. 3 times 3 is 9. 1 times 12. 2 times 6. 3 times 4. Right? What's a factor that they have in common? It's 3. Okay? 9 divided by 3. 12 divided by 3. Remember, if we're dividing the number of pieces that makes the whole thing by 3, we have to divide the number that we're talking about, the number of baby boys, by 3. Okay, so 9 divided by 3 is, now remember, if you forget, you can go, what times 3 is 9? 3, right? You can always think multiply when you divide if you get, like, what is that again? And then 12 divided by 3, once again, if you can't remember, you can go, what times 3 is 12? You can go right to left. 4 times 3 is 12 going this way. 12 divided by 3 is 4 going this way. Okay, so in simplest form, the number of babies born on Tuesday was 3/4. Awesome. Which of the following fractions is in simplest form? Okay, now we are on the back. Okay, you see the back? It's number 2. Now here's a super helpful hint, because Mrs. Olvey just looked at these. Zip! 2 different ways I found the one that was in simplest form. Okay? Way 1 is, I knew that 5/6 was in simplest form. I'm having issues with the color choices. I knew that 5/6 was in simplest form. Okay? Anytime the numerator is 1 away from the denominator, the fraction is in simplest form. 5 is 1 away from 6. Another example would be 3/4. 3 is 1 away from 4. I know that fraction is in simplest form. I mean, you can even think of like numbers like this, 15/16. I know that that is in simplest form because the numerator is 1 away from the denominator. So that's one way. The other way is, look at B, C, and D. Every single one of those is, guess what I'm writing before I finish? Are you yelling it out? Yes, every single one of those is an even number. Okay, what's a factor of every single even number? Okay, your divisibility rules. You remember? Even numbers are all divisible by 2. So every one of these fractions, B, C, and D, can be simplified by dividing at least by 2. That might not be the greatest common factor, but I know they're not in simplest form. So there are 2 reasons that one was just screaming, A, A, right? Okay, friends, let's keep going. We are down in review world, okay? This is chapter 2, lesson 12. Ashley bought 4 packages of juice boxes. There are 6 juice boxes in each package. She gave 2 juice boxes to each of 3 friends. How many juice boxes does Ashley have left? Okay, so this would be in the, sounds like a multi-stepper, doesn't it, guys? Does it sound multi-steppish to you? Because there's a lot of information. Let's go back. You know what I'm going to do, reread it. All right, what did Ashley do? She bought 4 packages of juice. So just for a little visual, there are 6 juice boxes in each package. Okay? So she bought that many juices. Okay, guys? You don't have to draw the model, but sometimes if you haven't done one of these in a long time, it's like, wait a second. Okay? So she bought 4 packages of juice. There are 6 in each package. Check. See how you can break this down sentence by sentence? Don't let it overwhelm you because you're too smart for that. You just have to pause and think and persevere. Don't give up. All right, now let's see what Ashley did. she gave 2 juice boxes to each of 3 friends. So she gave, right? So she gave away from this. How many did she give away? So here are her 3 friends. Each friend got what? Got 2. Okay? So 2 times 3, right? She gave away 6 juice boxes. So how many juice boxes does Ashley have left? Oh, well, look at this. If she gave away, you can even look at it like 2 plus 2 plus 2. She gave away 6, and she started with 4 sets of 6. Can we just do this? Yeah. She gave away one of the packages, didn't she? So what's left? Boop, boop, boop. 6 times 3. 3 packages of 6 juice boxes. 18. Okay? The other way you could have done this is you could have done 6 times 4 is 24, and then you could have subtracted the 6 juice boxes. That still would have gotten you 18. Okay? It was kind of cool, though, looking at that 6 and going, I'm just taking a package out. Okay? So Ashley had 18 juice boxes left. Fantastic work, guys.